In this lesson, we're going to see a type of technical drawing called an oblique. Obliques are similar to other pictorial drawings in that they show us three sides of an object in one view, giving us a 3D effect, but they have some characteristics that make them a little different from other pictorials. In an oblique drawing, the front-facing surfaces are seen straight on, a lot like an orthographic view. Vertical lines are drawn vertically, horizontal lines are drawn horizontally, and most importantly, arcs and circles are drawn at their true size and shape. The depth lines of an oblique are all drawn parallel, at the same angle, usually 45 degrees. The front-facing surfaces of an oblique are drawn in the same way as the front surfaces on a one-point perspective. The difference is that the depth lines in a one-point perspective converge toward a vanishing point, making some longer than others. That makes one-point perspectives difficult to dimension. Isometric drawings use angled lines for the depth and width, which causes all surfaces of the object to look skewed. Squares look like rhombuses, circles look like ellipses, and so on. Oblique drawings get around some of these skewed-looking features by showing all front-facing features at their true size and shape. Oblique drawings come in two varieties, called CAVALIER and CABINET. CAVALIER obliques use the correct measurements for all lines in the height, width, and depth direction. The funny thing is, this causes an optical illusion that makes the object look, at least on paper, as though the depth is too long. If you were to measure the length of the lines, they would be accurate, but for some reason this style looks a little off. Cabinet obliques try to correct this by shortening the depth lines by half. This style is named after the cabinet-making industry where it was developed and used so that customers could have a more accurate look at what their cabinets would look like in real life, while still seeing the door and face design straight on. A lot of kids learn to draw obliques when they make their first 3D drawings without even realizing it. Have you ever heard the trick that you can draw a 3D cube by simply drawing a square, then drawing another square, and connecting the corners with straight lines? If you've ever done this, then you've drawn an oblique. As I said earlier, one of the advantages of an oblique drawing is that it shows the front-facing surfaces of an object without distortion, making them easier to dimension. This is especially helpful with arcs and curves because they can be tricky to draw accurately in isometric or perspective. So that means that when you're selecting the best front view for an oblique, it helps to choose the view with the curves. When the true shape of a surface is important, obliques might just be the best choice. This collection of obliques is used to show different shapes of metal stock so that the customer can see the true cross-sectional shape of the material they want to buy. Creating an oblique drawing using a grid can be a little tricky. For these, we use a standard orthographic grid with vertical and horizontal lines. The problem is with drawing the depth lines, since they are drawn at 45 degrees. The most accurate way to do this would be without a grid, using a T-square, a 45-degree drawing triangle, and a ruler. Then you would be able to draw your 45-degree depth lines at exactly the right length. With the grid, if you draw a depth line from corner to opposite corner, you will get the correct 45-degree angle, but the length of the line will be a little too long. For this reason, if you're going to draw obliques on a grid, use 2 full grid spaces in the depth direction for every 3 spaces that you would use in the height or width direction when you're making a cavalier oblique, and use 1 full grid space in the depth direction for every 2 spaces in the height and width direction for cabinet obliques, which will help shorten up the depth dimension and make it look a little bit more accurate, even though the depth lines are shorter than real life. Let's see the steps to make an oblique drawing of this puzzle piece. I'll use the scale of 1 grid space equals 1/4 of an inch for this example. The blue surfaces are my front-facing surfaces. These are the ones that will be drawn on the grid lines at their full size and shape. When drawing an oblique, always start at the front and work your way to the back. Following this guideline, I'll draw the front square first. It's 0.75 inches wide and 0.75 inches high, which makes it 3 blocks by 3 blocks on my 1/4 inch grid. Now, before I can continue drawing any more front-facing surfaces on my grid, I need to draw some depth lines to take me back to the plane where those surfaces will be drawn. The next front-facing surfaces are 0.75 inches back from my current plane, so that's going to be 3 diagonal grid spaces from the corners of my square. Using my 2/3 ratio to keep my depth lines closer to accurate, I'll fill in these 0.75 inch depth lines as 2 diagonal spaces instead of 3. Once I reach that depth, I can fill in the width and height lines that make up the back edges of these surfaces. As you can already see, my Cavalier oblique doesn't look much like a cube, even though the measurements of the lines is 3/4 of an inch in all directions. Now that I've stepped my depth back to the plane where I need to draw my next front-facing surfaces, I can start to fill those in, again following my grid lines for the vertical and horizontal lines. Now I have all of my blue front-facing surfaces complete. All I need to do is add depth to these new faces. Again, this will be 2 spaces in the depth direction instead of 3, and then I can fill in the back horizontal and vertical edges of the surfaces. My Cavalier oblique is now complete. Now let's see the same object in a cabinet oblique for comparison. I start the same way, by filling in the height and width lines of my frontmost surface first. Now when I go to draw my depth lines, I'm going to shorten each one by half. So instead of drawing them 2 diagonal spaces to represent 3/4 of an inch, I'm going to draw them 1 space deep. Now for the next set of front-facing surfaces. From here, I can draw my next set of shortened depth lines and reconnect my edges on the back surface. Just like that, my cabinet oblique is finished. See the difference? Even though the depth lines on the cabinet oblique are shorter than they should be, the visual effect is that the object is in proportion. Try drawing a few obliques of your own. With a little practice, you can add this skill to your technical drawing toolbox. Thanks for watching.